Swayam Prabha. Digital India. Educated India.
So this is the lecture about rise of modern science in modern Europe. By the second half of the 17th century, a mechanistic view of the world was created. The scientific revolution refers to the speculative and unprecedented growth of intellectualism in the 16th and 17th centuries. The foundation of the modern worldview were laid during these 200 years, and tremendous advances in various branches of science were made. By the second half of the 17th century, a mechanistic view of the world was created. It changed the men's perception of the universe. There was an attempt at divorcing the material world from the spiritual world. Empirical observation and scientific method now attained importance and not religious belief or speculation. The centuries-old earth-centered concept of the universe replaced by the new concept of sun-centered universe. It was discovered that sun itself was one among millions of stars. This intellectual development in European society led to a rethinking of moral and religious matters as well as men's ideas on nature. Scholars stated the process by which this new view of the universe and the knowledge of science came to be established is termed as the scientific revolution. It changed in men's perception of the universe. Observation of natural phenomena, formulation of laws or principles on the basis of experiments and conclusions were the chief features of the scientific revolution. This lecture has been divided in 5 sections. The first section will be origins of modern science. Second, the social context of European society from Renaissance to the 17th century. Third, the major developments in modern science. Fourth, the formalism of scientific method. And fifth, the science and religion. J.D. Bernal has divided the period of scientific revolution into 3 phases. The first phase is the phase of Copernicus, when the geocentric view of the universe was replaced by the heliocentric concept. Second, the time of Tycho Brahe, Kepler, Galileo provided scientific basis to this view of Copernicus, and thus they have proved his theory further. This was the period of Newton, that is the third period, the period of Newton and Descartes. During this period, scientific societies were formed and science was becoming an institutional part of European society. Let's discuss the first section of this lecture, that is social context of modern science. There are alternative approaches explaining the origins of modern science. Marxist writers argue that the development of the scientific revolution arose in direct response to the needs of early capitalism, especially trade and navigation. R. Hewlett argues that the process of discovery of the New World, the knowledge of the new lands in Asia, Africa and America, their plants, animals and people created a fresh interest in the natural world. He rejects the notion that the progress and achievements in the field of science was confined to the domain of science alone. He stated, in order to understand the rise of modern science, one needs to examine factors which created favorable climate for it, ranging from theological issues to the rise of new social classes in modern European societies. For some, the rise of modern science was the product of society, and there was a direct relationship between these two, society and the modern science. While some other argues that scientific development was independent of society, in which individuals' qualities played a decisive role. A. Coire, Arthur Koestler, these historians argued each event in the development of modern science was independent of society and was unrelated to it. The development of modern science was the product of individual genius. Another historian, Herbert Butterfield, uses phrases like an epic adventure or a certain dynamic quality to describe the scientific events. He points out the wider changes in the world that affect men's thinking or even alter those conditions under which this thinking takes place. He emphasized on the role of technology, which played a crucial role in the development of modern science. Alexander Coire gives credit to the unparalleled insight of individuals. He stated, it is difficult, rather impossible, to define the scientific revolution. For him, its achievements were based on an admixture of genius, insights, delusion, and error. According to him, the scientific development was more accidental and considered the scientific revolution as almost the personal creation of a single man, Galileo. Arthur Koestler, next in the line, suggests that the scientific development was essentially a sketch of great individuals whose achievements were governed by individual qualities rather than the demand of the society. A.C. Crombie and M. Cleggett emphasized the progressive aspects of science. They thought that the scientific revolution was not so unusual or revolutionary as was made out to be. Crombie points out that modern science owed much of its success to the use of the inductive and experimental procedures, constituting what is often called the experimental method. Charles Webster also emphasizes the vast scope of science and says that by ignoring religious, political, economic, and intellectual movements from the study of science, the scope of science could become extremely limited. This would drastically reduce the scope of history. Marxist writers have provided social interpretation to explain the development of modern science. Boris Hassan links the scientific development to the needs of the bourgeois class. He suggests that Newton's work was related to the needs of the English merchant class. Frederick Andrews wrote, if a society had a technical need that helps science move forward and performs the role of more than 10 universities in any society and civilization. He further says there was no place for unique genius in the materialistic interpretation of history. He believed science to be a product of social needs. Edgar Gelseil also believed that modern science was the product of changing society. He suggests the beginning of science was greatly influenced by the achievements of ancient mathematicians and astronomers and medieval Arabic physicians. He gives the example of the period of transition from feudalism to early capitalism. He relates the emergence of modern science due to the societal needs. The spirit of science could not have developed in the rural setting of feudal knights or clergymen. Rather, it emerged only in the towns and cities. The introduction of new technology and technical inventions were related to the demands of production and warfare. The individualism of the new society is a presupposition of scientific thinking. The critical scientific spirit could not have developed without economic competition. While tradition and custom ruled feudal society, capitalism is governed by rationalism. So, a capitalist society provided the necessary condition for the rise of scientific spirit in 14th to 17th century European society. Gelseil's sociological interpretation thus emphasizes the three distinct strata of intellectual activity between 1300 and 1600 in which universities, humanism and labor contributed to the rise of scientific spirit. Christopher Hill treated science as a general social phenomena linked with the rise of Puritanism and the rise of bourgeois. He included science among other factors that were responsible for the English Civil War. According to Hill, the merchants of London established Gresham College to promote the study of science. H. F. Kearney argues that there was no direct connection between economic and scientific developments as argued by some of the Marxist historians. The rise of commercial revolution in the 16th century and the subsequent scientific revolution were not necessarily linked, as there is no valid body of evidence to suggest that connection. The revolutionary discoveries in science had no practical application, according to Kearney. However, in his conclusion, Kearney does not rule out the possibility that social changes did have some reflect in making the scientific revolution. In the 17th century, new wealth was acquired by a greater number of scholars who could afford more leisure time than before. More men attended universities than at any other time before, which meant that a greater number of men were receiving training in abstract thought, particularly mathematics. Social changes of this kind, according to Carney, it could be a decisive factor in the rise of modern science. This is the larger debate which we have discussed till now among the historians regarding the causes responsible for the emergence and the origins of modern science in European society, European world. Most scholars of social science now agree that the rise of modern science was the product of social needs and historical progress. Let's discuss the origins of science. The ancient Greek world had played a crucial role in shaping knowledge of science. Aristotle in physics, Ptolemy in the field of astronomy, and Galen in field of medicine, they had dominated European thoughts for centuries. In the medieval world, theologians studied the world, especially astronomy, based on the conclusions of the ancient Greeks. Medieval scholars continued the study of astronomy and medicine. Another factor which engaged the intellectual interest in the late medieval period was magic. There were various sides to magical inquiry. Alchemy was seen as a secret formula of nature, while the theory of atomism suggested that all matter was made of tiny particles whose composition could be changed. Astrology was another field that attracted the condition of medieval scholars. They claimed that the natural phenomena were understandable and predictable if the planetary movements were properly interpreted. The origins of modern science are related to two events. First, the discovery of the New World, and the second one is the Renaissance. The discovery of the New World rationalization that the earth revolves around the sun. The search for new territories and the long distance voyages created desire to develop the science of navigation. It created interest in science and technology. Improvements were made in the knowledge of machinery and technology. Water wheels were introduced in mining activities. Improvements could be seen in the field of metallurgy, military equipment, navigation and shipbuilding, and in the printing industry. The discovery of ancient Greek texts by Renaissance scholars brought Europeans closest to the modern science. There was a definite relationship between modern science and Renaissance. A serious study of nature based on observation and experiment was carried out as the great contributors of Renaissance wanted to find explanations for natural phenomena, for natural world and for their curiosity. Descartes argued that the Renaissance of the 15th century was not merely a revival of classical studies, but also a renewal of close, painstaking research. According to him, Leonardo da Vinci, also a natural philosopher and a pioneer in many realms of science, can also be seen as an anticipator of Galileo, Newton, Bacon, and Harvey. Although known for his paintings and masterpieces of sculpture and architecture, he has spent most of his time in the study of mathematics and cosmography. Herbert Butterfield suggests that the Renaissance witnessed an upsurge of ability that was scientific and pre-scientific age. Solutions to the problems of nature provided the elements of modern science during the age of Renaissance. The contribution of the Renaissance to modern science can be seen in several fields. Kenneth Clark suggests the basis of all the theories was the assumption that painting was concerned with the accurate representation of the visible world, and this was scientific basis of Renaissance naturalism. Alberti believed that no painter could paint without a thorough knowledge of geometry. Knowledge of nature could be improved on with the aid of the mathematics, and for this end he advocated the use of mathematical system of perspective known as the focused system. Many of the artists seem to lean on science to attain perfection. Different historians have emphasized different aspects of Renaissance as contributors to modern science. Almost all the great artists of 15th and early 16th centuries attempted to incorporate mathematical principles and mathematical harmony in their paintings, with realistic perspective as a specific goal for them. Herbert Butterfield thinks that the scientific attitude to art can be seen in the accurate and detailed knowledge of the structure of the human body. The knowledge of mathematics and geometry was used to ensure correct proportion in the field of art and architecture. The practical needs of every city states consisted of fortification of towns, greater utilization of minerals, systematization of accounts, accurate preparation of maps, and improvements in artillery. Greater sea voyages required more knowledge of navigation and the skill of cartography. Renaissance introduced the concept of the universe as an independent entity to science. Experiments were carried out during the Renaissance, but there was no formulation of general theories. The development of the Renaissance created skilled artisans and engineers, but surely they did not create true scientists. Renaissance was the work of artists and artisans, but not that of scientists. Next section is major developments in the scientific revolution. The scientific developments have been divided into two categories: micro cosmological and cosmological. The microcosmological consisted medical science, anatomy, physiology, pharmacology, pathology, etc. Modern physiology is usually associated with Harvey, who discovered the circulation of blood. It was also an important time for the development of biology, botany, and chemistry. Robert Boyle became the leading experimentalist and theorist in the field of chemistry. The world of cosmology. In the field of cosmology pertaining to the theories of the origin, creation, and evolution of the universe, important contribution made in the 16th century. The development of algebra, trigonometry, and introduction the decimal speeded up calculation and contributed to the field of mathematics. Scientists and their contribution to the scientific revolution. First in the line is Nicholas Copernicus. His contribution in the field of modern science leading to the scientific revolution. He argued that sun was the center of universe. It demolished the traditional views concerning the world, the Aristotelian system of universe. Tycho Brahe followed Copernicus to some extent, supported heliocentric theory, that is the sun-centered perception of the universe, thus came up with a compromise between Ptolemaic and Copernicus theory of the universe. Johannes Kepler further provided solution to these problems. He proved the planets moved around the sun in an elliptical orbit. He combined the observations of planetary positions observed by Brahe with his theories of planetary motion, which made it possible to predict the movements of celestial bodies more accurately than before and was of great help to navigators. Another prominent scientist was Galileo Galilei. He perceived a connection between the earth and planetary motions. He totally rejected the Aristotelian concept of universe. He argued that only those qualities which were measurable, for example, mass, weight, speed, and acceleration, could form the elements of the science of mechanics. He developed a new explanation of physical laws. Next in the line is Isaac Newton. He made an effort to unite laboratory experiments with mathematics. He laid foundations of modern calculus. His major achievement was his formulation of the laws of universal gravitation. He explained first the absence of force motion continues in a straight line with uniform velocity. Second, that the forcing acting on motion determines the rate of change of momentum. And the third, that every action has an equal and opposite reaction. His work, Optics, is very famous. Using a prism, Newton successfully revealed that light could be separated into different colors. He constructed white light by combining these colors. Newton's work Principia considered as the greatest work as regards originality and authority of knowledge in the whole history of science. He rejected supernaturalism in the presence of physical universe. He was the first person who did it, completely rejected the notion of supernaturalism from the physical universe notion. Albert Einstein resolved many of the queries that were left unresolved by the Newton and his former scientists. The next is the formulation of scientific method. Here we will discuss two scholars, two thinkers, two scientists. The one is very well known English scientist Francis Bacon, and another is a French philosopher, scientist, mathematician René Descartes. The two thinkers Francis Bacon and René Descartes made major contribution by highlighting the forms of scientific study within which should be adopted to promote scientific learning. The two great thinkers suggested contrasting methods of scientific studies. One suggested science, another suggested purely mathematics. The great instauration and new Atlantis of Bacon was the new philosophy that contained the seeds of scientific method. By instauration, he meant a recovery of unknown wisdom that would be procured through an entirely new scientific method. He emphasized on the cooperative effort for learning and empirical experiments for useful knowledge and the betterment of human life. He focused on the methods of inductive reasoning from observation and verification by experiments. The another philosopher, very well known philosopher, is René Descartes. René Descartes believed that all past knowledge should be discarded and one should begin afresh with every new problem. He was a rationalist and an advocate of mathematics. He advocated mathematics as an instrument of modern science. He emphasized that nothing should be accepted as truth and everything should be doubted till it is proved through deductive logic. His principle of doubt undermined the traditional assumptions. He made rationality the point of departure in his philosophical exercise. He made rationality the point of departure in his philosophical exercise. He reconstructed the universe on the basis of speculation that differed in every way from the universe created by the Greek scholars. He deducted two principles. One, since the idea of perfection was by men, an assuredly imperfect being, the idea may have come from a perfect being, that is, the God. According to René Descartes, therefore, God exists. And B, the second point, since the mind cannot be doubted, but the body and the material world can be, the two must be radically different. From the second principle followed on absolute dualism between mind and matter, it explained that the world was a pure mechanism governed by its own physical laws and without any intervention of God. Thus, Descartes created a philosophy of dualism, maintaining a sharp distinction between the body and soul. God created only these two kinds of reality. Mind belongs to man alone, while all else was matter. He argued that the entire universe could be studied objectively without the help of theology. He believed that the activity of the mind was the vital element in the search of truth. The real radical aspect of Descartes' thought was the changing role of God from being an active controller of the world to the guarantor of knowledge. He compared the role of God with watchmaker, who stopped interfering in its daily functioning once the watch was manufactured. Many alleged that he encouraged atheism, but he remained a faithful Roman Catholic and accepted the existence of God in his philosophy also. He developed a liking for mathematics because of its certainty of proof and the evidence of reasoning. His most important work was on geometry that laid foundations of analytical geometry. He introduced a system that could solve problems of space by numerical calculations based on algebraic and arithmetical methods. The followers of Descartes were known as Cartesians. Their view of mechanistic physics was based on the view of Descartes himself. He argued that matter consists of tiny particles which fill the universe. These particles are in a state of constant motion. He considered the universe to be full of continuously rotating particles and totally rejected the idea of vacuum. He claimed also to have deducted the properties of the whole universe using similar mechanical principles that were involved in the design of machines. The mechanical philosophy of Descartes insisted that an explanation of physical process has to be provided in mechanical terms. The mechanical presentation of the world meant that all natural bodies consist of nothing but particles of matter acting upon each other, that comprising our sensory organs. The suggestion of mind and matter in Cartesian dualism had tremendous impact on psychology and philosophy. Cartesian's philosophy also had some impact on the women's consciousness. The old Cartesian concept suggested that a woman possessed a distinctly female nature, which was mostly sinful. The Cartesian, on the other hand, suggested that sex differences are secondary, bodily, and indeed mechanist in type. Men and women are same basic human forms with a few difference of machinery. In dualist philosophy, mind and body are quite separate, and that made one of his followers to declare that mind is without sex. Paul de la Barre supported feminism and female education policies. He advocated female education. He stated that women are superior to men by virtue for her motherhood. He suggested gender equality, as women is in all essential respects as an identical with men in respect of mind and soul. Another scholar from Descartes Philosophy, G.E. Stell, talked of the organic unity of soul and body and claimed that women have sensibility that is as much physical as mental. Descartes' mathematics and skeptical method provided a base for modern science, and his views on mastering mind and matter has influenced contemporary thought of European society. The principles of scientific inquiry and the method of science began to receive serious attention from the intellectual community throughout Europe. In Newton's time, science gradually became an institutionalized feature in some societies of Western Europe. Several contributors of science such as Gilbert, Kepler, Harvey, Galileo, and many others promoted the climate of academic science. Many academic scientists established to promote and diffuse science in their respective societies. In London, Gresham College became a center for scientific discussion and research. There were many people from different professions, members of aristocracy, mercantilists, and scholars and thinkers of natural philosophy who contributed to the formation of such societies in their countries. These institutions and societies came into existence because of the wider support and finance received from ruling houses. Among the earlier members of English Royal Society were William Petty and Robert Boyle, who became famous through their contribution to mechanical or agriculture innovations and scientific studies, respectively. Charles II, an English ruler, patronized the Royal Society. The members came from diverse social backgrounds in support of science. The real object of these institutions was to promote science and bring scientific contributions or the contributors to a common platform. In this society, new scientific outlook was dependent purely on intellectual grounds and not because of its usefulness. In this process, technology as a branch of science did not receive sufficient attention and promotion only took place during the 18th century with the coming of industrialization, first in Britain and then in European society. Now we will discuss some of the debates regarding science and women and the science and the role of religion in the development of the science. So let's first discuss the science and the women. Women remained out of the formal scientific institutions. Very few women educated and from wealthy family got opportunity to be the part of these scientific institutes. Some women even came forward to patronize scientists and their work. Some women from aristocratic family got opportunity for the formal education which was not available to the common women of European countries and society, and thus they invested their interest in science. Margaret Cavendish, the Duchess of the Newcastle, had written many articles related to philosophy of science. Ground of Natural Philosophy is the most famous among others. Though she attended one of the meetings of the English Royal Society but could not get formal membership of that institution. In Italy also, women registered their entry in the scientific field, scientific society, but they too could not become formal members of these centers. In Germany, women were working in craftships. They interested in science, especially in cosmology. Maria Vinkelman got support from her father and uncle in her self-study. She was married to the famous scientist Karach, who was appointed at the high post in Academy of Science in Berlin. Maria had assisted her husband and thus contributed in the field of science. But after the death of her husband, despite her several applications, she could not get the formal membership of any scientific society. Thus, it could be concluded here that in patriarchal society, the contribution of women in scientific work neither welcomed nor encouraged. The science was kept safe for the menfolk only. The next is science and religion. Recent debate addressed the relation between the Protestant Reformation and the rise of modern science. Some historians like Max Weber, R.K. Morton, S.F. Mason and Christopher Hill participated in this debate, and they have argued that the experimental science was the product of Protestant ethics, while some other argued and suggested that it originated in the Catholic countries, especially in Italy. So this is a debate first at the first level that that Protestant played a crucial role in the development of the science, or it was the Catholic reform movements or Catholic religions which provided a platform for the beginning of scientific development in European society. Protestant Reformation promoted the rise of Western capitalism. It also promoted active life and scientific experimentation. R.K. Merton stated the early Protestant ethos was expressed in scientific thought, and thus it helped in the development of scientific mentality and scientific approach in the European society. R.K. Merton stated that the early Protestant ethos was expressed in a scientific thought. Calvinism emphasized on good deeds. Scientists also considered important hard work and the experimentation. He also argued there is a definite combination between the minute details of the political doctrines of the Calvinism and the principle of modern science. Calvinism emphasized on good deeds. Scientists also considered important hard work and experimentation. He also argued there is a definite combination between the minute details of the political doctrines of Calvinism and the principle of modern science. He suggested Protestant religious values, particularly Puritan, created an intellectual atmosphere that helped scientific development. S.F. Mason too supported the close link between Protestant and modern science. For him, the Anglican Church and the Royal Society may place equal claim to the world of Reformation, the one encompassing in religion and other revealing it in philosophy. Christopher Hill, in his works, The Century of Revolution, which is the very famous one, and the intellectual origins of the English Revolution, he argues that the scientific development was an ordinary social happening along with the rise of Puritanism and the bourgeois class in England. He argues Puritanism revolution in England had a strong scientific element. There are other thinkers refute the argument that the rise of modern science was related to the spread of Protestant Reformation in Europe. Their major argument is that all religious leaders and Pope were against scientists, for example, Copernicus. H.F. Kearney rejected the argument of Hill, though he accepts it is possible that a more critical attitude towards religious authority created a climate of opinion that was scientific in approach. Other historians like T.K. Rao criticizes Hill and others who linked the development of modern science with Puritanism. He points out that Catholic Italy was the only center of scientific experiments in the early period of modern science. According to him, all important scientists of that period lived or studied in Italy. However, he argued after 1640 the Puritan did contribute to the emergence of modern science and the further development of modern science. But according to him, it was Italy, it was Catholic religion which provided a base for the experimentation of modern science, for the development of modern science. Next, we'll discuss William Ashworth. William Ashworth, in his work Catholicism and Early Modern Science, suggests that many Jesuits had a keen interest in experimental science. They participated and practiced science at wide scale. They were able investigators, made many important discoveries and inventions, and encouraged others too to participate in modern science and in the field of scientific work, and promoted thus scientific attitude among their followers, among their people. Toby Huff gives a culturist interpretation of the rise of modern science. He says, cultural differences and revolutions that emphasized rational studies of nature based on study provided a lead to the European countries over China and Arabs, who were till 14th century far ahead of Europeans in the field of science. However, it was not cultural but economic differences which prevented further progress of China and Arabs in the field of science and also in the field of economic, political progress and development. In conclusion, we can say Reformation contributed to the atmosphere of intellectual activity, though a direct relationship between the Reformation and the scientific revolution is difficult to establish. The rise of modern science was a product of urban society, yet individual contributions also played a significant role in this process. Both Catholic and Protestant accepted the reality with the changing economic and social conditions. She summed up her own achievements regarding foreign policy. She summed up her own achievements regarding foreign policy in the following words: I came to Russia as a poor girl. Russia has doved me richly, but I have paid her back with a job, the Crimea and the Ukraine. Now we will discuss some of the limitations of enlightened absolutism. Apart from all these welfare policies of enlightened despots, kings, they could not bring about lasting solutions. In the long run, enlightened absolutism proved to be a failure. It failed due to its inherent limitations. They acknowledged that rulers existed for the good of the people, but they denied that they should be directed by the people. The success of such a system depended solely upon a single person. When weaker rulers succeeded the efficient rulers, the whole machinery was thrown out of gear. Enlightened despotism was an enlightened reaction to the evils of the old regime in Europe, but this reaction was too feeble to turn the tradition of monarchical absolutism upside down. Not all reformers among the European rulers could be enlightened despots, because the basic requirement for the purpose of identification of enlightened despotism was the connection between the kings and philosophers. The legal reforms, particularly the codification of law carried out in name of the Enlightenment and to a certain extent reflected the aspiration of the philosophers. However, it is difficult to establish any direct link between the Enlightenment and the practical policies of the monarchs. The chief among the enlightened despots were Frederick the Great of Prussia, Catherine II of Russia, as we have seen, Maria Theresa to some extent, and then her son Joseph II of Austria-Hungary. The most enlightened rulers were often least successful, as we have seen in the case of Joseph II of Austria. Thank you.